Thank you for that incredible introduction, Andrew. It's much appreciated. Hopefully I can live up to it. Good evening, everybody. My name's Steve Shepherd. I'll do some introductions in a moment. And I'm going to take a little bit of your time this evening to talk about one of my favourite subjects, which is malware. Malware is one of the many forensic disciplines that you may have come across for those involved in forensics and cyber investigations. And you may have been subject to a malware infection at some point and have used antivirus in order to find it and remove it. This evening, hopefully I'm going to talk a little bit about some malware. Perhaps you know some of this. If you don't, feel free to ask me some questions after the presentation. So without further ado, let's move on with the presentation. Hopefully we can see this. Yep. So first and foremost, this is a picture of me, of course, and my background. I first started doing digital forensics in the late 90s. That's a long time ago. Following an investigation that I was involved in that involved a computer. Investigating the computer sparked my interest in how we can actually do it properly. And I ended up founding the Military Police High-Tech Crime Unit in the early 2000s in order to investigate cybercrime involving computers, of course. Throughout my career, I have been involved in forensics with the military. I've been involved in online investigations for the film industry. I was the online anti-piracy manager for FACT. I also worked for the States of Jersey Police in their forensics computer crime team. I've also been a civil servant in a government department in Gloucester somewhere. Can't really talk about that one. But I did work there for 4 years and 1 day, if you're interested. Following that, I joined an organisation called 7Safe. Perhaps some of you have heard of that. 7Safe used to deliver cyber training, penetration testing and forensic training and services. 7Safe was bought out by a technical consultancy called PA Consulting, whom I'm a part-time consultant for, as well as a part-time lecturer, as a senior lecturer practitioner at Anglia Ruskin. So I actually do what I teach. I wrote probably 8 or 9 forensic courses that I deliver to industry, ranging from network investigations to complex malware investigations and so on. So that's enough about me. Let's get on with why you're here this evening. So there are only 3 types of malware. Some of you may know this, some of you may have a different view, but essentially there are only 3 different types. There is a virus. You've probably heard of that word before. Most people say when they get infected by malware, they have a virus. The chances of them having a virus are quite slim. It's probably a worm or a Trojan that they have. So there is a virus. There are also worms, and you may have heard of that term before, and Trojans or Trojan horses. This is the only 3 different types of malware that there are. All the different malware that you see must fall into one of these 3 categories. And if it doesn't, then it's just not malware. So what I'll like to do now is talk a bit more in depth about these 3 different types. And then, of course, how can we find these 3 different types? Because what we need, like any forensic investigation, is a methodology. Once we've got a methodology, we should be able to find that pesky malware in the event that your antivirus is not able to find it. So if it's quite complex malware or 0-day, perhaps you've heard that term before, that is to say, the antivirus solutions can't detect it using their signature database because it's unknown to the antivirus solution at that time. So let's just talk about what a virus is. So essentially, a virus is a piece of code, according to Google, that is capable of copying itself and has a detrimental effect? Well, of course it does. Yeah. It could corrupt your computer, and it could be a bad day for those that have a virus. The chances of you being infected by a virus today are very slim. I'm not saying that it couldn't happen. I'm just saying it's very slim. Most malware today is either a worm, but more likely than not, it's going to be some sort of Trojan variant, some sort of Trojan horse variant. So how can we describe a virus, and what can a virus do? You may have asked yourself those things before. So a virus is just simply a piece of malicious code that attaches itself to a file or some other medium. So what we mean by that is it needs to attach itself to a file somehow. It can hide inside the file itself. It can hide at the beginning of it, somewhere in the middle perhaps, or indeed at the end. So it needs to hide inside a file in order to be a virus. And interestingly, that's why the first piece of malicious code was called a virus, because it hides inside somewhere, just like a real virus hides inside a cell. So it hides inside a file or another medium. So the other medium might be, for example, a boot sector, and you may have heard of that term. So the boot sector is basically the first sector of the first logical sector of a device. And when that is loaded, or when your computer's booted up, there may be malware or a pointer to the malware that enables the malware to infect your computer. So that's essentially how we would describe a virus, a piece of code that attaches itself to a file or some other medium. So you may well ask, well, what can a virus do? And that's quite interesting. A virus actually can do anything it's coded to do within the confines or the permissions of the account under which it's being executed. So for those that have an account of a normal user, it will only have the privileges of a normal user. For those, and I may suggest that's most of us, have an account that has administrator privileges. If you get infected by malware, then guess what? The malware would also have administrator privileges when it's initially infecting your machine. It may elevate its privileges further later on. But as we can see there, it's handy to know that if you have an account that's administrator, you may want to create another account that's not, just in case you're subject to a ransomware infection. And for anybody that's interested in how to minimize ransomware infection, please ask me after the presentation. I'll be more than happy to talk about ransomware. So let's move on. So that's a virus. Let's talk about a worm. What does Google say about a worm? It's a self-replicating program able to propagate across a network. Again, typically having a detrimental effect. That sounds good. And indeed, that is in fact correct. So how would I describe a worm and what I believe a worm can do? So a worm is actually a self-contained program or set of programs that is able to spread functional copies of itself or its segments, so that's just part of it, across a network. Typically taking advantage of network misconfigurations and vulnerabilities. Okay, so this just basically means malware can spread functional copies of itself across a network from one node or one computer to another node or another computer, and it will infect that computer across a network. What can a worm do? Well, anything it's coded to do within the confines of the computer that it's infected. As you can see here, unlike a virus, it doesn't need an account in order to infect the computer. A virus does, but a worm does not. What does that mean for us? It simply means that if your computer is switched on, it can be infected with malware without you actually logging on. And that's quite the case today with various malware infections, such as CryptoLocker and other types of malware like that. It just doesn't need you to be logged on. It can just simply infect your computer if your computer's switched on and it's connected to a network. As I mentioned before, it will take advantage of network misconfigurations and software vulnerabilities. That includes application software, such as a program you're using, and indeed operating system vulnerabilities as well. So you need to make sure that your computer is patched regularly and you don't go on the internet to places where one shouldn't really go. I'll say no more on that. Okay, so essentially that's a worm. Let's talk about a Trojan horse, and you may have heard of this before. So what does Google say about a Trojan horse? A program designed to breach security on a computer system whilst ostensibly performing some innocuous function. Again, that's absolutely correct. How I would put this to my delegates or students is like this. So I would describe a Trojan horse is malicious software that hides its presence on a computer whilst performing a nefarious function. It has no other purpose. It will hide in your computer and do something. That something will be nefarious. It may not be obvious to you. It may just collect information. Perhaps it will steal data, perhaps your banking details, and send that back to the person that created the malware. So what can a Trojan horse do? Well, that essentially depends on how complex the malware is, but essentially it can do anything that it's coded to do within the confines of the account, the user account, and or the computer. So this means it doesn't actually need a user account to infect your computer necessarily, but it can do so as well. And once complex malware is on your computer, it's able to elevate its privileges beyond that of a simple administrator and be quite difficult to detect with modern detection mechanisms. Hopefully, the antivirus will have a signature of the malware that's infected your computer and it will detect it. But if it can't detect it, I'm going to talk about a couple of ways where you can go and find the malware yourself. And this is what I teach to industry. And perhaps you could find something that the antivirus or the security systems couldn't find. So that's the three types of malware that we have. All malware must fall in one of those categories. And today, malware is named by its actions. So if it's got Trojan horse capabilities, it'll be a Trojan horse. A number of years ago, that wasn't necessarily the case. And some Trojan horses were identified as worms, and they're still classed as worms today, when in fact they are Trojan horses. So today, malware is classified by its highest classification. If it has capabilities of Trojan horse and worm functionality, it's still a Trojan horse. If it's a worm that has Trojan horse functionality, it's a Trojan horse. So hopefully that gives you an understanding of how malware is categorized today. Right, that's enough about me talking about malware. Let's just talk about how we're going to find it. So malware must exist in one of two states. So it only exists in one of two states. Those states are referred to as presence and infection. You may have heard of these terms. You may have heard of just one of them, perhaps the word infection, such as my computer is infected with a virus. So let's just talk about that. So presence is just that. Presence just means the binary or the executable, the malicious code that makes the malware do something, is on your file system. That's what it means. So you may have downloaded it by accident, or it may have got there by some other nefarious capability. And your antivirus has detected the presence of the binary on your file system. So the malware has a signature within the antivirus database, and essentially that's how it's detected. It's identified a number of bytes at particular offsets, and that's how it knows it's a particular type of Trojan or a particular type of worm. If it's 0 day, that is to say it's not in the signature database, it simply won't identify it. All malware today, by the use of antivirus that you have at home, typically will identify presence. That is to say, the malware is on your file system somewhere, typically in your user area, although it could be anywhere. Okay, next is infection, and this is the bit that's more interesting. So this means that the malware has been executed and now it's running in the memory of your computer. Then, and only then, can malware have an effect on your computer. Okay, so it can do whatever it's coded to do whilst it's running. Okay, it must run in memory. So once the malware is running, we now have a number of permutations about how we can find this malware. So the malware may be running in the memory of your computer, and the original binary that it was executed from may also still be on the file system, but it may not. So you can have presence and infection, or you can have presence and no infection, or you can have infection and no presence. So there are different permutations we can have with regards to the malware. If we have presence and no infection, if we have infection and no presence, this means that the malware is fileless. You may have heard of that term, and is quite difficult to detect because it's only running in the memory of your computer. It doesn't have any executable on the file system. So it can be running in memory and on the file system. It can be on the file system and not running in the memory, or it can be running in memory and not being on the file system, or any permutation thereof. Hopefully that wasn't confusing. It was confusing for me, but that will give you a better understanding of malware terminology. So persistence and infection. Right. So malware can be non-persistent or it can be persistent. What that simply means is when you switch your computer off and then switch your computer on, it might not be there, or indeed it might be there. So if the malware is non-persistent, that simply means if you restart your computer or your browser or some other application, depending on what started the malware, it will simply go away and not restart. Obviously, some malware does do that, but most doesn't, such as ransomware. Ransomware wants to persist just to remind you that your files are encrypted and you owe some money. You owe some digital money. So non-persistent just means it's only there while your computer's switched on or while you've got a particular browser session or some other application running. Then we have persistent. Persistent simply means that the malware can withstand a reboot. So there's a mechanism to restart the malware, either following a system reboot or following a logon of your user account. So it can be either or. So it can just simply restart when your computer switches on, or it can just simply restart if somebody logs in. There are different mechanisms to enable a computer to persist on your computer. These restart locations, there are several of them. I'll just mention a couple of them for you, such as the task scheduler. You may have heard of these things. There are startup keys for those that have Windows computers in something called the registry. That's just a database that holds settings and stuff. There are startup folders. There are scripts and a number of other different methods by which malware can persist. It must be in one of them on a file system in order for that to occur, typically. So we've talked about malware and how it can persist or not on your computer. What we'd like now, this is the final bit of the presentation. Hopefully I've not sent everybody to sleep, is we need a methodology in order to find the malware. So if your antivirus is not working today and you're convinced you have a malware infection, you need a methodology in order to find the malware. The methodology can be investigated in any order. And if the malware is running, it has to be running on your computer, or there is persistence, it must be in one of these 4 methodologies. So the methodologies are the places one needs to go to identify artifacts of interest that would indicate either the presence and or infection of malware. Malware investigations typically are conducted on a live computer. They can also be conducted on a switched off computer, on a static computer, but there are limitations if you conduct an investigation on a static computer. Typically, I conduct investigations on a live computer, and if somebody gives me a forensic copy of a computer that they suspect has malware, I'll just restore it and boot it up as a virtual machine or a clone in order that the computer's running so I can do my investigation. So let's just talk about the methodology. There's 4 of them. As we can see there, I've got 4 pictures, and I'll just talk briefly about these 4 pictures, and that will then be the end of my presentation, and hopefully you've found it sort of interesting. So we have ports, processes, files, and startup. These are the 4 areas or our methodology that we need to look for to find artifacts of interesting. So the first one is ports. You may have heard of this term before. So malware needs to either receive commands or access a network to send stolen information or perhaps some other information about the computer it's infected to its owner. So it needs to have a network connection. Network connections on a computer are held in RAM. They're held in the memory of the computer. And so we need to investigate a live computer in order to find active network connections. So for those that are involved in forensics, a process, which we'll talk about in a minute, is just an instance of an executable running in memory, but it needs some additional software in order to connect to a network. And the operating system provides that in the form of something called a socket. I don't mean the thing that you find in a garage. A software is just essentially some software created by the operating system that binds that process to a port number, to a transport protocol that enables that process to communicate on a network. That is to send and or receive data from a network. So an active process essentially needs a socket in order to communicate or receive communications from a network. So we need to be in memory in order to find that. The next methodology is processes. Again, as I mentioned before, a process is just an instance of an executable running in memory. And for malware to infect your computer, one of 2 things must be happening. It must either be running as a process in its own right, that is to say, it might be called bob.exe running on your computer, or it must hide itself within another process or purport to be another process, perhaps a genuine process, in order to obfuscate its existence, in order to hide itself from you and from security solutions so that it can affect your computer and do what it needs to do. So it needs to run as a binary in its own right, or hide itself within another process, or obfuscate itself with another process. It's one or the other. The first one is a lot easier to find, of course, a binary running its own right. As investigators, and for those that do malware investigations, we're always interested in executables running from a user area. Typically, that's what happens initially when you get a malware infection. It's going to execute somewhere from your account, and then if it elevates its privileges or it moves around your computer, it might hide somewhere else, perhaps in some system folder somewhere. So processes essentially need a number of things in order to function. and you may have heard of these terms. They need something called threads and handles. A thread essentially is nothing more complex than the method by which machine code is sent to the processor for processing. All processes must have at least one thread, and a handle is just a logical connection by the process to something, such as an area of memory or something in memory, or perhaps a file on the file system. And so when we're doing investigations of suspect processes, we like to know what they're touching. We like to know how many threads they have, and then we can generate, if we haven't already, something we refer to in industry as a known good configuration. So we would know what a genuine process should look like, and we can compare that to our suspect process, and it might give us an indication that it could be malware, or it might contain malware if it's hiding within the process itself. So we've got ports and processes. Now you may say to me, if we're investigating a static image, how we can find that? Well, we can only find historical evidence that a process had occurred. And for those that are involved in traditional forensics that are attending the meeting this evening, typically this would be MRU lists and prefetch files to identify the names of executables that have run on your computer. I'm not here to teach you forensics, but obviously we're interested in investigating those and using tools to access metadata within the prefetch files to identify in detail the file name, where it was executed from, how many times it's been executed, the total times it's been executed, and the last 8 times or so it's been executed with more granular information. So together with all the DLLs and all the associated files it needs to function. So there are various locations we can find those on a file system. So that's processes. Again, feel free to ask me a little bit more if you're interested in processes after the presentation. So next is files. Hopefully, when we've done our live investigation and we've identified suspect ports and or suspect processes, we've managed to identify the executable on the file system. We've used some other product to narrow down our suspect executables, and we can then have a closer look at that suspect binary on the file system. Maybe that's the one we're looking for. There are a number of things we can then do when we identify the suspect binary, the suspect executable. We can query it with PowerShell to find some interesting information about it. And once we've identified that it is the suspect malware that we're looking for, we can then reverse engineer it, so we can decompile it and then work out what its capability is. So what we're looking for is what API files that it actually calls into itself, and then what we're more interested in is what calls are made to those API files to make it do something. So the example would be there. We're always interested in executables that can create and delete files, create and delete registry keys, create and delete sockets. Oh, yeah. And create and delete accounts. That's interesting. And finally, create something called a mutex. So you may have heard of this term before. For those that are involved in complex investigations, mutex is just a short term for mutually exclusive object. Essentially, that's just a unique identifier running in memory that essentially tells another executable with the same unique identifier not to execute in memory, because we only want one piece of complex malware running at one time. Otherwise, your CPU will get quite busy and you're likely to be more suspicious that there's something going on. So there are some examples there of finding the capability of complex malware if it's not doing anything other than creating a socket. because it thinks you've found it. So complex malware can actually determine that you're trying to use tools and techniques to identify it, and it may choose to do nothing. So we've got ports, processes, and files. Finally, if it wants to withstand a reboot and persist on your computer, we need to identify a startup mechanism. And I've already mentioned a number of these in my presentation already. These are typically the run keys. The run keys are generally in the registry for the computer and for you, the user. So there is a subkey called run that will have a value in it that will point to an executable that will start the executable either when the computer is rebooted and or when you, the user, logs in. So it can be either or. It just depends what the malware has been coded to do. If the hacker's not bothered about who's using the computer, essentially the malware would start as soon as the computer's booted up. But if you wanted to target a particular account you found on there, you could also do that as well. So this information is essentially held in run keys. We've also got startup folders. These are exactly what they say. They're just directories. There are startup folders for you, the user, and of course for the computer. And essentially, malware can put a shortcut or the executable itself or some other mechanism so that, again, when the computer boots up or when you log in, the malware will execute. So that's just another mechanism. Other mechanisms, as I mentioned earlier on, are the task scheduler. So when a given event has occurred, such as the computer booting up or you logging in or you starting a process, another process will then be executed by the task scheduler. So this can also be used when a particular date and the time occurs, and so on and so forth. So essentially, these are referred to as events. So when a particular event occurs, the task scheduler will execute that pesky malware. So that might mean, for example, when we're investigating a computer, a live computer, the malware may not be running because an event has not yet occurred. And if it does occur, the malware may only run for perhaps 5 minutes to have a look around, collect something, and then go to sleep again. Okay, so it will terminate its executable and it will not re-execute until a particular event has occurred. So that's a bit more complicated if that was the case. Other methods include scripts. Okay, so a script is just a bit of code in some sort of file that will execute. Again, the task scheduler can execute scripts, and obviously a script can be executed when a particular event has occurred from the user by clicking something or accessing something. And a script, again, can just execute something. Typically, hackers today want to make use of PowerShell in order to collect information and then exfiltrate or copy that information out of your computer back to the hacker. PowerShell is the hacker's choice today, and typically it's executed with a command prompt. So the malware will have the ability to run a command prompt, and then it will execute PowerShell commands through the command prompt. And that's quite simple to do for those that may not have used PowerShell. You just invoke the command PowerShell and then give it the right syntax to do something. Hopefully the PowerShell script will run. And if it won't, we just change something called an executable policy. There's a number of ways we can do that. That will enable the script to run irrespective of what that executable policy is. We can just change it or bypass it. That's a bit more hacky and doesn't form part of this presentation, but feel free to ask me after the presentation if you so wish. So we have ports, processes, files, and startup. And once we've identified the artifacts, we're going to put those together so that we can write a report that may indicate the time and the date the malware first gained presence on your system. perhaps when it was executed, what it did it create anything? Did it save anything? Was there any network communication? And so on and so forth. And then depending on who you work for, or perhaps the reason why you're doing your investigation, you can then submit that report as evidence of what has occurred. Luckily for us today, there's lots of software solutions that can enable us to do lots of malware investigations, from sandbox environments to real life environments to virtualized environments, including live environments. So there's lots of ways for us to do that and identify that pesky malware. The reverse engineering, again, is a discipline in its own right, and that's just understanding the machine code that compiled the binary, compiled the executable, so we can work out, if we so wished, what its proper function is, its proper capability. Because when we're doing our live investigations, again, as I mentioned before, perhaps it's not doing everything that it's capable of. We've got our methodology, ports, processes, files, and startup. I'm mindful of the time. I can keep talking forever. But essentially, because there's some questions, I think I'll hold it there. So thank you very much for being subject to my presentation on pesky malware. And if anybody's got any non-difficult, non-technical questions, I'll endeavour to answer them. Thank you very much.